The webinar has started. Hello everyone. Welcome to our student webinar. And now we are going to play the video of WPC Chairman Thomas Bingley.
Happy World Plumbing Day. I'm Tom Bigley.
Is it audible?
Yeah, very much. It's audible, it is not running, but.
Plumbing Council Chairman and Director of Plumbing for the United Association of Plumbers and Pipe Fitters from the United States and Canada. On March 11th, every year, people from all over the world will celebrate World Plumbing Day. This all started 12 years ago when the WPC established this date to bring awareness to the public that plumbing cannot be something we take for granted. We want to show our communities the responsibilities that plumbers have in protecting their health and, more important, educating them on ways to conserve our dwindling resources for the future. I'm here today at my nation's capital, Washington, D.C., at the United Association of Plumbers Local 5 Training Center. Here in the lobby of history are some of the early plumbing systems of this city. Although our country is young compared to the plumbing systems of India and Europe, our infrastructure is crumbling and in need of repair and replacement. That's why I chose today's location for World Plumbing Day's message. If we want safe, reliable drinking water and proper sanitation, it all starts here with training the next generation of plumbers. Every year, young adults from all over the world must decide on a career path for themselves and their families. It is essential that we promote the plumbing industry as a profession to ensure that we can continue to provide a good quality of life for the next generation. Here at the Plumbers Union, we take over 10,000 new apprentices every year at over 250 state-of-the-art training centers like this one that are scattered around the United States and Canada. These classes not only include waste, vents, and water systems, but also medical gas, backflow prevention, safety curriculums, and water reuse. Here in the rainwater harvesting training module, this facility captures all the rainwater and repurposes this for the flushing of water closets, urinals, and all the water to supply the wet training laboratories for teaching. By facilitating the training needs of our contractors and end users, we are expanding their employment opportunities, which makes it a clearer career choice for the next generation of workers. Fair wages and benefits, continuing educational opportunities, and not to mention a safe workplace environment will continue to attract critical workers for the future. It's 2022, and we are talking about the pandemic, which has killed close to 6 million people, and yet we are silent on the fact that over 800,000 people die every year from inadequate water, sanitation, and hygiene. World Plumbing Day raises awareness of this terrible but preventable statistic, but more needs to be done. The perception of good plumbing deserves to be recognized as a frontline solution to preventing diseases from taking away the lives of our children. Here at the World Plumbing Council, we work with global organizations like the World Health Organization, Messe Frankfurt, IWISH, and the World Skills Competition to support new technology and training seminars that promote clean, sustainable water and sanitation. To increase our voices, we need your help. Get involved by joining the World Plumbing Council. Share a link on your Facebook page or request proclamation from your country that recognizes March 11th as the World Plumbing Day. The more publicity we get, the more attention will be drawn towards funding to build critical plumbing infrastructure throughout the world. Also this year, the World Plumbing Council Conference will be hosted by China in beautiful Shanghai on October 13th to the 15th. Please join me and our entire World Plumbing Council family in exploring new products, new technology, and plumbing practices. The world is a small place. We must all work together to preserve our resources for our children and their children. Help me in celebrating World Plumbing Day by thanking all the plumbing installers, the plumbing manufacturers, the supply house workers, plumbing engineers, sewage and water treatment plant workers, and especially our plumbing instructors, for without their sacrifices and efforts, we would not be able to train the next generation of skilled plumbers. Thank you, and remember that the plumber protects the health of all nations.
Happy World Plumbing Day!
Now let's stand up wherever you are for the national anthem. I'm sharing the screen.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Hello and welcome everyone. I'm your host Santosh Sharma. Thank you for taking the time to join us today as we talk about basic of plumbing. Now, Student Chapters convener Mr. Milind Shetty will share the opening remarks.
No problem. एक करवा के दूसरा लेटर दे देते हैं अपना
Sir, you are on mute.
एक में चेक करे करवा आज तो नहीं कल.
Am I audible now, Santosh? Okay, great. Thank you. Thank you. Hello, everybody. A very good evening and warm welcome to all the present delegates to this first Student Chapter National Webinar on the subject Basics of Plumbing. Friends, we all know that 11th March is celebrated as World Plumbing Day every year, and we at IPA celebrate this day as our Founders Day also. This year, along with the traditional activities, we also decided to add a series of national technical webinars for our student chapter members, where our expert speakers will enlighten the students on subjects which will be enriching your knowledge. So I would like to appeal all the students to grab this opportunity, to earn the knowledge by attending the webinars on 15th, 16th, and 17th, every day on 5th to 5 p.m. to 6:30 p.m. Now, moving ahead, I think plumbing, I always feel that plumbing was a long neglected subject. Maybe due to the stigma attached to that subject, that this is a second grade job or a job not to be done by the engineers. In older days, maybe say 30 or 40 years back, if you see, the buildings were small. The horizontal as well as the vertical expansion, both was limited. And the plumbing too was simple. But now gone are the days. The structures have become more complex. The requirements, the demands of the occupants have increased. The systems have advanced in a very different, at a very different level. And so gone are the days when illiterate or maybe an unskilled plumbing professional used to handle the or can handle the plumbing installation. Now, the plumbing designers will be in great demand. Rather, I will say the plumbing engineers or the plumbing professionals will be in great demand, considering the construction of such complex buildings. And that is why I again appeal all of you to grab this opportunity and to attend all the other future 3 webinars which will be conducted ahead. Plowing back to our today's session, Mr. Mukesh Asija, who is our NEC member, Chapter Delhi, IPA Delhi Chapter, and my colleague will be delivering this paper on basics of plumbing in some time. Till then, I hand over the mic to Santosh to take it forward. Thank you.
Okay, now,
Over to you, Santosh.
yeah. Thank you, sir. Now I'm going to share a screen for the sponsorial video.
KPT, Flow Infinite. Modernization is an indispensable aspect for any society to thrive, grow, and develop. Rapid urbanization requires robust infrastructure development and building construction. Every industrial and commercial construction requires a non-corrosive and eco-friendly advanced plastic piping system. Here comes KPT Piping Systems Private Limited, an ISO 9001-2015 and ISO 14001-2015 certified company with the advanced European technology PPR piping system. Operational since 2008, KPT is India's #1 industrial PPR piping solutions provider. A leader in polypropylene random copolymer piping systems, PPR Piping System has a state-of-the-art multi-specialty piping manufacturing facility.
Sorry for the inconvenience. I'm sharing the screen again.
KPT, Flow Infinite. Modernization is an indispensable aspect for.
Is it playing, sir? No?
Let's stop.
Just a second.
Any society to thrive, grow, and develop.
Is the video visible and audible?
Yeah.
Okay.
Yeah, now it is visible.
Modernization requires robust infrastructure development and building construction. Every industrial and commercial construction requires a non-corrosive and eco-friendly advanced plastic piping system. Here comes KPT Piping Systems Private Limited, an ISO 9001:2015 and ISO 14001:2015 certified company with the advanced European technology PPR piping system. Operational since 2008, KPT is India's #1 industrial PPR piping solutions provider. A leader in polypropylene random copolymer piping systems, PPR Piping System has a state-of-the-art multi-specialty piping manufacturing facility and uses non-toxic food-grade, highly strength, fusion weldable raw material for the production of its piping systems. To ensure world-class quality, KPT brings to you a piping system made with R200P PPR raw material, 100% Hyoseong from the Republic of South Korea. PPR pipes are eco-friendly and 100% food-grade material and resistant to most of the chemicals. PPR piping system is now widely used in the fields of drinking water, compressed air, cooling towers, firefighting, acids, RO, DM, ETP water applications, offering a longer lifespan of 50 years. With world-class PPR raw material and state-of-the-art production facility, KPT has successfully completed 2,500 plus complex projects for various industrial, commercial and government organizations. Our piping system is now running for most critical applications like data centers, injection molding factories and chillers all over India. Our product ranges: pneumatopipes for compressed air, green therm for water applications, thermoplast for firefighting system, KPT's manufacturing facility, lab, infrastructure, etc. KPT has a full-fledged and fully automated manufacturing facility with a capacity to produce 15 metric ton pipes per day. The unit has a fully equipped lab for material testing and quality assurance. The company adopts a stringent quality control process to ensure our customers get only the best anytime and every time. Our achievements: winner of India 5000 Best MSME Award for outstanding contribution in quality and excellence in the realm of customer satisfaction. Pride of Bharat for the year 2021 for the most trusted pipes manufacturer and suppliers of the year. Our esteemed members: FIEO, Federation of Indian Export Organizations; CII, the Confederation of Indian Industry; EEPC, Engineering Export Promotion Council. We believe innovation and quality are the key to deliver world-class products. For over 13 years, we are working to deliver excellence to all our stakeholders. KPT, Flow Infinite.
Yeah. So this year we started regional webinars from 2nd March to 10th March in 8 different languages. And on 11th March, we celebrated World Plumbing Day and held a national webinar. Now, just a second, I'm sharing our presentation. Yeah. So on 14th to 17th March, we are conducting the 4 student chapter webinars, and still we have like our social media contest is still going on till 17th March, and you can also uh, participate in this contest, and you can also go through our social pages for more information. Now I'm going to introduce our speaker, Mr. Mukesh Asija. Chairman of IPA Delhi Chapter. Mukesh Asija is a principal consultant and managing director of Akrim Engineering Services Private Limited and MEP Building Services Design Consultancy established in 1985. He graduated from BITS Pilani in 1979 with a degree in civil engineering and then did his master's degree in civil engineering from the University of Delhi in 1981. He has worked in India and abroad with reputed consultancy practices. His project experience spans designing and coordinating engineering services for a township and build developments in residential, commercial, institutional, and hospitality. Mukesh Asija is the chapter chairman for IPA Delhi Chapter. Now, I would like to invite Mr. Mukesh Asija.
Good evening.
Very good evening, sir. Very good evening. Very good evening. Mukesh, you are audible.
Yeah. Good evening, young engineers. I'm really glad to know that you are interested in knowing something about plumbing. As my friend Mr. Milind Shetty just said, that this has been the most neglected discipline of engineering. There is no doubt about it. Perhaps there is a stigma. He is right in saying there is a stigma attached to it. But you, as the budding engineers, must understand that how important this particular thing is. It is so, embedded in our life. Tomorrow morning, suppose your plumbing system is not working. Just see, can you manage your daily life without that plumbing? Can you go to your college? Can you attend your classes? And to be honest, if you have not relieved yourself, can you eat throughout the day? No. So it is, though it's neglected, but it's very important. And as young engineers, you must take it to new heights. You must understand its importance. I my request is that whatever I am telling you today, it is on the I will be sharing few of my experiences also with you. Just listen to me. There is no need of making notes. I am not telling you something which is a rocket science. You can get a lot of information in the textbooks, in the quotes, but just to make you have interest in this. So I would be sharing with you certain points which can be the starting points for your interest in this particular field. And the PPT which I would be showing you, it's not very well structured, which perhaps most of you are normally accustomed to. It's a basic, and most of my interaction with you would be verbal. 1 minute, let me just start this. Is my screen visible?
No, Mukesh ji, not yet. Not yet.
Not yet. Okay, 1 minute. 1 minute. Is it
Yes, it's
visible?
visible. It's visible. Perfectly visible.
Okay, young budding engineers, you know what is plumbing? It's very simple definition of plumbing is it's a set of pipes and fixtures installed within a building. Please mind my words. Within a building to supply required quantum of water of desired quality at optimum pressure and to collect the used water and convey this used water to a disposal point outside that building. This is what the plumbing is. And the safety of the user is the essence of the plumbing. When you are supplying water through a plumbing system, it is for the safety of the user. And when you are conveying and or collecting the used water to a disposal point, again, the safety of the user is of prime importance, that it doesn't leave any kind of nuisance. Now, how this word plumbing got evolved? Uh, Many of you would be knowing what is plumb. It is a tool which you might have seen masons, tile layers, and stone layers using it for various things. This is called plumb. Now, if we go back into the history of how the mankind evolved, how our residential habits got evolved. Earlier, for easing ourselves, nature was there. We used to go to the fields. Then we started having that place of easing ourselves within our premises. That time, more developments, population, people used to stay on the ground floor. That place of easement was on the ground only. It started with the manual cleaning of that place and bringing water to that place of easement or the place of washing through buckets. Then came the concept of bringing water or conveying the used water through drains or through pipe drains. The next step of in that evolution of our living style was having storage houses. Initially, even in the storage houses, the place of easement used to be on the ground floor. If you look at all the old houses, if they are in the initial same state, you will find that place of easement was used to be on the ground floor. Then the mankind thought, why not have that place of easement on the floor where we are staying? So there, those vertical pipes system for conveying water for usage and for collection and conveying to the point of disposal, used water started. And those pipes were to be laid in straight, absolutely perpendicular form. Like a mason does a wall or a tile layer puts the tiles on a wall. Absolutely in plumb. So those pipes have to be in plumb. That's why the term plumbing got evolved. Now the plumbing can be divided into two subdivisions. This is the logical subdivisions. One subdivision is water supply. We use that supplied water for the purpose for which it has been supplied. Once the water has been used, it has to be drained. So the second subdivision of the plumbing is drainage. In between is the human being or any process which is using that water and converting into the leftover water into the used water. Now, when we start with the first subdivision, water supply, how much water is to be supplied? Then from where that water comes or from where that water may come. Perhaps that water which we are getting is not fit for consumption directly. So you have to do the treatment. That water may not be available throughout the period of your usage from the source. So you have to store it. Then you have to provide a mechanism of distribution. And finally, a system of dispensing from where you draw the water and use it. Now, how the demand is assessed? Again, the process of assessing the demand got evolved over a period of time by collecting data. Like when you cook a dish in your home, if you have to cook 1 kg of rice, depending upon the quality of the rice, you might have heard your mother saying, okay, for this much of rice, for 2 bowl of raw rice, you have to put 8 bowl of water. So that in a way becomes a scale of consumption. Similarly, over a period of time, by collecting the data, these scales got evolved, and many of these scales are now available in the codes. So when you assess the water, depending upon the purpose of that assessment, you refer to the codes where many of these scales are mentioned for different kind of occupancies, or you try to understand the process, like the example I have given, the rice making in your home, and then work out the consumption pattern. So first, this assessment of the demand is the first step. Now, for example, when I say you have to refer to the codes, so this is a page I have taken from the National Building Code, where different kind of usages are mentioned or types of buildings are mentioned, and the scales of consumption either on the basis of per head, per resident, per bed, per seat are mentioned in this. So on this basis, when you know in a building how many occupants would be there, how many users would be there, you refer to these codes and work out the total expected demand. Once that demand is worked out, you provide for the other systems accordingly based on that assessment of the demand. Demand you have assessed, but from where to get that water? For that, you must understand the hydrologic cycle or the water cycle. See, water on this earth is limited. Only thing is, it keeps on changing its form from one form to another form. We have a lot of water bodies, including sea, from where the evaporation takes place. It gets condensed. Then there is a precipitation in form of water or in form of snow. That water, the precipitation in form of water flows down through the naturally formed or man-made drainage systems or over the surface, and then come back to a collection area, or it gets infiltrated into the ground depending upon the quality of the surface. The condensation which has precipitated over the as snow, that also melts over a period of time, and again through the natural channels like rivers, comes down, gets collected in lakes or into the river, which finally meets the sea, and again the same cycle starts. So in this entire cycle, which we call hydrologic cycle or water cycle, we draw the water for our usage, and after our consumption, it is again put back into the same system. The only thing is, while we use it, we pollute it. And that level of pollution the marks or maintains the quality of our ultimate water sources. If we are polluting our water, suppose you have to take the water for your usage from this lake, that is before this water overflows into the sea and gets evaporated, you have collected because you are not staying on the sea. So now, if you are discharging your used water into the same lake, this water will become unusable for you. Similar is the case for infiltration. If you are letting the water, that dirty water, used water, polluted water, infected water into the ground, and you have done a bore well and you are drawing that polluted water for your use, so that will create a problem. Of course, all these issues in subsequent webinars would be taken, but basically I want to tell you that water on this earth is limited and it follows a particular cycle. It keeps on changing its forms and come back to the same form again. Now coming to the sources of water, as you have seen in this hydrologic cycle, we have sources like rivers, lakes or ponds, and sea. These are classified as surface water sources because we can see the surface of that water. The other source of water is a subsurface water, the water which has got infiltrated into the ground. So to draw that water, we have to drill the bore wells or the tube wells. So once we have identified our source, or if a source is available to us, depending upon the quality of that source, we have to treat that water. That water source may be pristine, perhaps you don't require any treatment. Like if you go up hills where habitation is very less and water is flowing crystal clear, you can drink it right from the river itself. It doesn't require any treatment. But then, because of the habitation, increase in population, the way we use it, or because of other characteristics of the surface runoff which is going into those our water sources, impurities do come into those rivers, lakes. So we have to treat that water before we use it. Now these impurities are of three types. Physical impurities, water may be having floating waste material, can be just twigs, leaves, paper. It may be having physical impurities which have settled down at the bottom of your water source, or it is in a suspension form. It may be sand, it may be silt, or any other metal. Then there can be chemical impurities. These chemical impurities may be natural or created by man. Natural in the sense, suppose it is a surface water which is flowing over an area. When it flows, it may carry with it the salts which are there already on that surface over which it is flowing, or it is creating when it is flowing, it may be flowing over rocks. Those rocks may be having salts. So those salts also get mixed up. That level of those chemical impurities may be above the threshold level. See, for our human consumption, there are some levels specified that water, if those parameters are above a certain level, then water is not good for us, for our consumption, for various reasons. Most of them have the medical issues. Some of them have just the aesthetic issues or potability issues. Then the third type of impurities are microbiological impurities. That is the bacterial impurities which might have just come into our water sources from the stream which is carrying dirty water, or decaying vegetation in that stream or that water body. So the extent of treatment and the type of treatment depends what kind of impurities are there. For each of these three type of impurities, a number of solutions are available. Today I won't like to, because this becomes a complete subject again, but you can refer books, you can refer textbooks, you can refer quotes for knowing in detail about these methods of removal. Or in subsequent webinars, my colleagues would be taking up these things in detail. So today let's have an overview of the plumbing and the concepts of plumbing. So let's move to the next point. So once the water has been treated, most of the time it needs to be stored. Why it is to be stored? If I am staying at a place and a river is just flowing or a stream of water is flowing next to my house, and I know that it is a perennial river or perennial stream, 365 days a year, water would be there. I can draw water any time of the day, any day of the year from that particular stream. I need not store it. But this doesn't happen everywhere and for everyone. Now that source is when the source is limited and it is not close to us, water has been conveyed to us through some other means. It may be through pipes, through tankers. So we have to store the water for the time when there is a disconnect between the source and our requirement. So that is the purpose of storage. That storage we can have underground, above ground, or elevated, or a combination of all these. That depends how we are getting the water, from where we are getting the water. The next question is how much we should store. Now, when we know that why we are storing the water, because it is not available to us 24/7, we have to find out that what is the duration of that disconnect between our requirement and the availability. Take the case of urban water supply system. How you get water? Municipality supplies you through a network of pipes. In those pipes, water flows because it is being forced into those pipes through pumps, or if your source is at the top of a hill, you are staying in a valley and your source is at a natural elevated place and there is a reservoir over there. A spring was flowing from further height, so someone has just created a storage in between, and from there a pipeline has been laid up to your place of consumption. So you are getting water without any pump, but still there is a pipeline in between. Now, if there is a damage to that pipeline, or if the source was, or a pumping system is also involved in that conveyance of the water to your place of consumption. If something goes wrong, there is a power failure, what do you do? For that particular duration, you must have the storage with you. Normally, in urban situations where we know that the responsibility of storing or the bulk storage of water is with municipality, we know that municipality has got a particular pattern of supplying water, or if there is any damage in the municipal lines or the pumping system, municipality, when I say municipality, even if you are staying in a gated colony, the facility management of that gated colony becomes the municipality for you. The fault which has come into the distribution system, if that you know that it can be rectified in 12 hours or in 24 hours or in 4 hours, so you decide the storage capacity. Now again, how do you know that it would be rectified in 4 hours or 6 hours or 24 hours? A pattern, over a period of time, a pattern gets developed, it becomes generalized. So normally for the residential population, urban, semi-urban or rural, not rural, I should not say rural, there the supply is still very erratic. The, the recommended storage is 1 day. It can come down to half day also if your municipality is very, very efficient and there have not been any cases of major breakdowns or stoppage of water. But generally half day to 1 day is the normal criteria. But then there are campuses, there are habitations where the supply is very erratic. Like we were, my office was a period of time would be around 20,000 people. The source of water is an irrigation. It passes by. But there is an issue. So what those 20,000 people staying in that campus will do during 40,000, during those 40 days. So their storage requirement would be very high. So they have to make arrangement for creating that kind of storage within the campus. So that is how the storage capacities are calculated. Of course, there are some thumb rules, there are some norms, but for each situation, one must evaluate whether I require this much of storage, will it be sufficient? Now take the case of a hospital. There are patients. Suppose there is a breakdown of municipal water, groundwater is not there. You cannot ask patients to leave the hospital. You cannot ask them to bring water from their house. So then in a hospital, the recommended storage is much more than what is there for a house or for a residential colony. Or, or take the case of an industry where there is a process going on which cannot be broken, cannot be stopped. And it is dependent upon the water. So there also you have to store it for all those eventualities, for the breakdown in supply system. when I say supply system, means piping, pumping, water treatment. So you have to store accordingly, evaluating the risk involved, what kind of breakdowns can be there, and what is the importance of the usage. Uh, then comes once you have stored the water, but before you use it, water requires a kind of a conditioning as per your requirement. That can be a quality conditioning. Of course, you have done the treatment, you have stored that treated water, but for some purpose, it may require further conditioning. The water which you are getting from the municipality or from other source, suppose it was having physical impurities which you have removed. Water is fit and there are no microbiological or you have handled those microbiological issues also. So water is fit for general consumption. But now you want to enjoy a cup of coffee or tea, which gives you a true taste of that coffee or tea or any drink of your choice. And that water which you are having has got certain salts which always add to the taste of the brew or whatever you have cooked. So naturally, to make that water a kind of neutral, when I say taste neutral, not the neutral in the other sense, you will have to remove those dissolved salts. Or if you are in the business of, you run a chain of tea or coffee shops. So whether that your outlet is in Bangalore or it is in Hyderabad or in Delhi or Srinagar, you want it to taste same everywhere. So you have to condition that water, bring it to the same level as far as the dissolved and taste giving salts are concerned, so that everywhere that brew which you are serving to your customers, it tastes. So this is called conditioning for the quality. Many times a membrane based systems are used so that those excessive salts are removed. Then next conditioning is the temperature conditioning. You may require cool water for the preparation of some brew or for cooking something, or even for the drinking. Or you may require hot water. Now, hot water you may require even for your washing and bathing purposes also. So before the water is supplied, this conditioning is done depending upon your requirements. And for each of these conditionings, there are a number of solutions. Now I will touch upon the heating because the bulk of the conditioning is required for supplying hot water for the sanitary purposes. Now heating you can do in a number of ways. That heat source can be in electricity, like most of us have geysers in our houses. It can be through solar, where you absorb the heat of the sunshine and heat the water. It can be by burning any fossil fuel. In the hot water generators, boilers, or be absorbing the heat from the atmosphere through heat pump. So these are the options for heating the water. You can read about these systems, their merits, demerits, the cost. Lot of literature is available. This itself is a topic of a full lecture. So sometime else, perhaps we will go into the details on this. Now, after the water has been conditioned as per your requirement, then it needs to be distributed. Now, when we say distributed, it can be direct to the point of consumption. Like I told you, suppose you are staying in a valley and you are getting water from an elevated reservoir. It may be a man-made reservoir or it may be a natural lake which has been tapped. A pipeline or a channel has been created. It is bringing the water to the valley where you stay, your house is there. You have tapped that pipeline or channel. You have connected it with your tap. You open the tap and you get the water. Similarly, if your municipal system is very efficient, 24/7, you know that water is available throughout the day, 24/7. You have connected your system with the municipal system, you open the tap and you get the water. But when that is not the case, you have to adopt other systems. You have to first store that water in an underground tank. From that underground tank, if you are staying in a storage house, you have to supply and serve all the floors above. So either you construct an elevated storage on top of your house, on top of that building. First, pump the water to that particular elevated storage, and then under the gravity head, you feed the floors below. Or you have a choice. You put a pumping system which starts and stops as per the demand. You open the tap, you get the water, that drops the pressure in the line. It is sensed by the controller of that pump, and the pump starts, and you keep on getting the water. Or you can have a hybrid system. The hybrid system is you have an underground storage, you have an elevated storage, and you have a direct pumping system also, either installed with your underground storage or through or with your elevated storage. The disadvantage of the why we resort to hybrid system, there is a reason for that. When we are staying in the storage houses and we are having this downfeed water supply system, the level difference between the elevated storage and the floors just below that elevated storage, the level difference is less. The water which you get from your faucets is at a very low pressure. In some cases, it just drips, while the floors below, they get good water at a very good pressure. So in a hybrid system, we can install a pressurization system on the terrace itself. So the top few floors are pressurized, and floors below that get water at the required pressure by gravity only. Then in the water supply subsection, the last point is the dispensing of water. You have distributed the water through pipes, but then you have to dispense it for the ultimately from where the user draws the water from the pipelines. Number of types are there for these faucets. Some faucets we require for our daily needs, like we use at our homes. Manually operated, you open a tap, or it can be a shower. Then in public places, the taps are provided with sensors. You take your hands closer to those faucets, it starts giving the water. You walk away from that faucet, it stops automatically. Or you might have seen faucets or used those faucets which are called metered faucet. That means in each operation of that faucet, a limited amount of water comes out. Those are called metered faucets. You would have used these in public, normally these are used in public places to reduce the wastage of the water and to limit the usage of water. Then when you require hot and cold water, so you require mixing faucets. Faucets where hot and cold water gets mixed and you get that water at the desired temperature from the faucet. One main thing which we must understand for the mixing faucets is, and this is a very important basic point of plumbing. In the mixing faucet, the pressure of the hot and cold water should be same. Then only a proper mixing will take place. Otherwise, suppose you are supplying water at a cold water at a higher pressure and hot water at a lower pressure, you will get cold water only, or water at a very low temperature. Similarly, if the hot water is being supplied at a higher pressure, you will get very hot water which you don't want. So how that is achieved? So the best way of doing this is the source of water for cold and cold feed to your hot water generation system should be same and without any pressure break in between. Like if you are getting water from the overhead tank, from the same overhead tank, the water should come to the cold water inlet of that faucet and it should go to the inlet of the, suppose you are having a geyser, to that geyser. The hot water which will come out from the geyser will also have the same pressure because that geyser is always full of water. It's a pressure vessel. So you will have a perfect mixing. But if you have installed another cold water feeding system for your geyser, which is lower than the cold water, the water tank which is feeding the water for the cold side of the mixing faucet, that pressure will not be the same and you will have those problems. Similarly, if you are supplying the water from a pressurized system, so you have to make sure that the water which is being sent for getting heated is also going from the same pumping system and not from a different pumping system. Then in addition to faucets for our daily needs, there are faucets which are for special purposes. You might have seen those faucets in industrial kitchens for washing dishes. Or you might have seen faucets with a doctor or in an operation theater where their hands are soiled and they don't want to touch. So all those faucets have very long levers. So those can be operated by the, and likewise there are many other requirements for which special purpose faucets are used. Am I running? How much time do I have? Hello.
Sir, we started late.
Yeah, I know.
You can take another 5 minutes, 10 minutes maybe.
Okay. Now the first subsection, I have already touched upon all the points. Now the next subsection is the drainage. See, once you have used the water through and it has passed through all those things which I have just touched upon: sourcing, storage, distribution, conditioning, water treatment, dispensing. Once you have used it, it becomes used or dirty water. Now we have to have a system of collecting that used water and conveying it safely without creating any nuisance to the disposal system outside our building. So drainage systems within building are two types. One is the underground and another is above ground. Underground system, when we say in earlier times, not now popular, neither permitted by the municipality. So go into the same system as your used water. And in your municipality, in your town, village, or city, it flows into the same system, but this is no more permitted, though still many towns, many cities in our country still have that system, but slowly it is getting replaced. So we handle the rainwater separately and we use water separately. Now then, the major component which concerns the plumbing system in any building is the above ground drainage. The system which collects water from your fixtures and faucets on all the floors and conveys it to the underground drainage system. For this also, primarily there are two types of systems, and there is a historical background about that. And now for two pipe system, background. For single pipe system, there is the advancement pipes. Now in two pipe system, your black water, the water which the wastewater which gets generated in your water closets, in your WCs, urinals, that is made to flow. And there is another pipe in which we call it grey water. Shower area, your washing is collected and conveyed. Why I am saying there is a historical reason for this. In earlier times, the grey water was let to go into your stormwater system, while the black water, the water containing soil, your fecal matter, was handled separately. That handling was done either through a system of septic tanks or improvised soak pits where the solids were separated and the liquid portion was made to percolate into the soil. The single pipe system is a relatively new system based on better understanding of the hydraulics of this above ground drainage system, plus the need of treating the entire used water for reuse purposes or for maintaining the quality of our water sources into which these used waters are ultimately at one point or the other is connected. See, the entire water which we used, where they are conveyed, this water after once we have used it, it gets connected to the city's drainage system, and where it is discharged, again, it doesn't get evaporated. Again, it is discharged into a water body, and that water body again are discharging that used water without any treatment. But again, if that is a flowing water body and it has got good quantum of flowing water, you have discharged little bit of used water into that, it gets mixed up, and down the stream, because of its own ecosystem in that water body, in that flowing stream, it gets treated. But that is not happening in highly populated cities and towns now. So we have to treat that water, the entire water, whether it is coming from our kitchen, from our washrooms, from our WCs, and ultimately it gets connected to the same underground drainage system. We can go for a single pipe system. Of course, when we go for a single pipe system, it has its own constraints, own safety measures, design parameters, which need to be considered before opting for this. Now the question comes, when you collect the used water connected with the outside drainage system, how do you prevent the smell which is there in the outside drainage system? All of us experience whenever there is a wastewater flowing, when you pass through drains, or if it is a pipe drain, its manhole is open, it emits a lot of foul smell. But why that foul smell does not come to our toilets? So a major and the most important component in the above ground drainage system is a contraption called trap. This trap is a contraption which holds water, which acts as a seal, and that seal prevents back passage of air from the sewer to the inside, but at the same time allows flow of used water through it for discharging into the sewer. I can show you some of these, how this trap looks like. Is this visible? Can someone tell me whether I am able to display it?
Yes.
Yes,
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 sir.
Mukesh, you are able to display. You are able to display. Sir, a request to just speed up a little bit because we should not get too late.
Okay, okay, okay.
What I should.
So
Thank you.
this is one type of trap. Uh, you put the water remains up to this level, so that the foul, and this end is connected with your outside drainage system. So whatever foul gases, foul smells are getting generated, this end is within your toilet, so that foul gases, foul air can't come as long as you are able to maintain the water seal in this. There are other forms also of this. The one which I showed you is a horizontal. Now, if you see, this is a vertical. In this, that water seal gets formed because of a vertical system. So all these information you can see in the codes, in the textbooks and other literature which is available. Next point in the above ground drainage system which is of importance is the venting. See, when we know that foul gases do get formed in the system, so those are to be taken out from the system. So venting does that purpose. Second thing is, in the above ground drainage, we know the pipes don't flow full. It's a mixture of water, solids and air. Because of, and when they, especially the whole thing goes down under the gravity head, a pressure imbalance gets created in the pipelines. Now, to maintain that pressure, the system venting is to be done. If this system venting is not done, the trap which I have shown you, which is preventing the foul gases, smells coming from outside to your toilets, that water seal gets sucked, because the mouth of that trap or the inlet of the in your toilet is at the atmospheric pressure. And if a subatmospheric pressure gets formed in the pipeline, in the above ground drainage, downstream of that trap, it will suck that water seal from the system, and the water in that trap will come down, and it will create a passage for the foul air, foul gases, foul smell to come inside your toilet. To know more about, if you are keen to learn more about the plumbing, these are some of the documents which I am suggesting. You can go through National Building Code of India, section part 9 is devoted to this particular aspect. Then there is a very good code. It's called Uniform Plumbing Code of India. It has been brought out to you by Indian Plumbing Association only. And Indian Plumbing Association keeps on updating with the latest research, latest trend globally. Which can be read, and as I understand, it is prescribed as a textbook also. by very famous plumbing engineer of our country, Mr. S.G. Devlalikar, very respected. In fact, he is called Pitama of plumbing in our country. So this book has been brought out by Tata McGraw, available easily. So you can read through these books. Plus there are a number of other books also. But to develop your interest, I am suggesting you please go through these documents. You will have lot of learning and you will have lot of questions. You can always Plumbing Association brings out a monthly journal also. Indian, it's called IPT. You can subscribe to that. You can become a member, I think. Do we give IPT to our student members also or not?
Yeah. It is to an extent we give it to the college.
Okay.
It is given to the college.
Great. So you can refer to that. You can communicate with us through that journal also. Thank you for listening patiently to what I have told you, shared my experiences. I know it was not a very structured thing, but I hope in this informal way, I have been able to make you interested in this particular field, and you will get benefited by 3 more webinars in this series. Thank you. Thank you for listening to me and showing your patience. Bye. Have a good day. Good evening.
Thank you, Mukesh ji. Thank you so much for a very and very insightful deliberation on basics of plumbing. I hope the students will definitely gain a lot from your deliberations. Now I would request Bhakti to take up the questions. Bhakti and even Asit sir also, they can take up the questions. There are few questions in the chat box. Bhakti, can you take up the questions or?
Yeah, sure, sir.
Yeah, please.
The first question is from Tulsi Ram, that which system is best, single or two pipe system? So very
okay.
Common question. Yeah.
It's not a question of which is best. Both have got its certain limitations. A single pipe system definitely consumes less material. If we see from the holistic point of view, the overall carbon footprint, and in a way, when we say carbon footprint, even the water footprint of your property comes down when we use less materials. But then there are set of norms attached while opting for this. If we are able, there are some special fittings also. And then there are some limitations on the horizontal lens. So if we are able to source those kind of materials and design following the codes, then definitely a single pipe system is a better option than two pipe system. But if you have to, if you have to treat the water in two different methods, if you don't have the facility for having a combined treatment, or the capacity limitations are there, or there are some other things, then one should go for two pipe system. So it's very difficult to say which is better. It varies from project to project. But yes, one thing is there, as we are learning more about the hydraulics of the above ground drainage, the global practice is to go towards single pipe system.
Thank you, sir. I hope it has answered your question. Mr. Ajay Kumar is asking, sir, there is an air pipe, but then also I'm getting smell in the washroom.
Okay. Now, there are two. Does that trap have the sufficient water seal, sufficient water depth, which is prescribed for that kind of application and that type of pipe size? See, there are certain contraptions available in the market. They are called traps only, but the reality is the water seal in those traps is almost negligible. So if the toilet is not in use for long, there is an evaporation, or the plumbing is not proper, or your water seal gets sucked because the depth of that seal is not much. Some negative pressure which develops in your stack momentarily, and your atmospheric pressure on inside your toilet is that pressure differential is there, so that much water gets wasted and you may have that smell. So please check what is the water seal in that, how deep is that trap. Normally when you connect it directly with your pipeline, a minimum seal of 50 mm, 2 inches is recommended. So make sure that kind of seal is there and it is maintained.
Okay. Thank you, sir. The next question is from Mr. Parth.
Yeah, what is the question?
The question, sir, is, sir, what are the design criteria for plumbing in high-rise building?
What are the?
Mr. Parth says, sir, what are the design criteria for plumbing in high-rise building?
No, there are a number of design criteria. What exactly he wants to know? Anyway, see, design criteria are basically same whether it is a high-rise or low-rise. You have to start from the user end. Like first thing is where the water is being dispensed, whether it is a high-rise or a low-rise. You have to have an optimal pressure, and whether you are staying in a 30-story building or you are staying in a single ground floor building, at your tap you need the same pressure. Now then comes, so that criteria is same. Now how to achieve that in a high-rise building? For that, you have to do the detailed engineering. How to get that much of pressure? See, in a high-rise building, suppose you are having an elevated tank, and building is say 45 meter or say 60 meter. Now, if you supply through a downtake system at the ground level, you will get a pressure of 6 bar, 6 kg, 60 meter pressure, which would be too high. So you have to use a contraption to reduce that pressure at the user end. Similarly, for if it is a single storied or two storied house, and again you are having a downtake system from an overhead tank which is sitting just above your terrace, you will get very low pressure. So you have to have a system of boosting that pressure. So the principle as such is same, get the right pressure at the user end and to have a system of collecting the used water in a safe way from the user end. How to achieve it? It again varies from project to project and from situation to situation and from height of the building. So if this gentleman can be more specific which principle he is referring to, whether it is related to design criteria or the design methodology.
Sir, the next question is from Mr. Girish. As per our experience, single pipe system cost around 2.5 times double pipe system. Is it correct?
No, no. He may be comparing it with two different materials. Pipes of two different materials. For double pipe, he may be considering a piping material which is relatively much cheaper, and for a single pipe, he may be referring to some proprietary item or a system being pushed by a particular manufacturer who may be selling it for a premium. So it is not true at all.
Bhakti,
Yes.
can we stop the question answers?
Yeah,
Because
time.
it's too late, I think. Santosh, just see that we answer all these questions on mail, IPA mail.
Yeah.
You send it to Mukesh ji, we can answer that to that.
Yeah, sure, my pleasure.
Because it is getting too late, so I think we should close for the day. If
Yes, sir, there is no question now.
There are two questions. Okay, I will note that.
okay, fine.
Or I can answer if there are two only, I can answer. Yes.
No issues. Please take it. Bhakti.
Yeah, the question is generally speaking, what is the life expectancy of pipes?
Okay. Again, it depends from material to material, but I tell you, even the plastic pipes, if they are of the right type of material, which is the quality as mentioned in the codes, and if these are really as per those codes, even the plastic pipes have a life of about 50 years.
Okay. The
metallic pipes have more, but again there is a rider on this.
Yeah.
It all depends what quality of water is being used. If the quality of the water is not good, then you cannot predict. Perhaps these pipes may give up in 2 years' time also, or perhaps earlier.
Correct. The last question is, how the number of fixtures needed for a one flat, and if we are designing for it 14 floors building with 2 flats at each floor. So this is actually
number of fixtures.
Yeah.
No, I think number of fixtures it's
depends.
It depends upon your way of living.
Yeah.
Like even a family of 10 also can manage with 2 WCs, and sometime these days the trend is in higher end houses 2 persons, different toilets.
Correct.
His and her.
Yes, sir. Yeah. Okay. Thank you for the questions. You gave answers in such a detail. And I'm very happy there were so many questions. So people were attending to it. Paying attention to your.
It was my pleasure also to share my experience, whatever little bit I know about these things.
Yeah. I'll give vote of thanks. I'm Bhakti Manke from IPA Pune chapter. So I would like to thank you, Santosh, for hosting this very knowledgeable webinar. Thank you, Milind sir, for such a wonderful speech. Thank you, KPT, for sponsoring this event. Thank you, Mukesh Asija, for such a informative session. And the topic was actually basic of plumbing, but you gave really in detail. Like everyone was very attentive, and also we got a lot of comments also in chat box that you cleared many of their doubts. So I'm very thankful to you.
No, but I would like to inform this audience, the webinars which would follow this
Yeah.
be much more interesting and much more, they will get much more and deep knowledge from those webinars. They should attend those webinars. They should not miss a single webinar.
Yes, yes, sir. And thank you. Last but not the least, I would like to thank all the participants who have attended this webinar. And we would like to have more attendee for the next webinar. So please share the brochure with everyone, the leaflet stating the seminar details. So we want more attendees. So thank you very much for this webinar. Over to Milind, sir.
Yes, thank you. Thank you, Bhakti. And I think we should close for the day now. Thank you. Is it okay, Santosh?
Yes, sir.
Thank you all. Thank you.
Okay, thank you.
Thank you, sir.
Thank you. Have a great evening.
Yes.